I get the fortunate pleasure to introduce potentially one of the funniest people ever, Warren Buffering. Yes, his hat is real. He does wear this thing in real life. But he is an excellent developer, and he officially used Elixir before me, so maybe I'm just drafting off of him. But I would really like it if you guys could give a very big, warm welcome to one of my best friends, Warren Buffering.
Check, check. Thanks for setting the bar so low. It's okay that I was introduced by the less handsome Aaron Francis, by the way. Are we on the screen? Sweet, we're on the screen. Thank you. Thank you. So what I'm bringing to you guys today is a highly technical dissertation that I submitted to the Department of Aeronautical Engineering. It's for the degree of Doctorate of Physics. It's not a big deal. Lots of people do it. But one thing about this talk is it is going to be interactive. So if everybody could look under their seats, I worked really hard with Carson to put this together. Okay, about half of you did it. Nice, perfect. That works for me. Apps are for writes, sites are for reads. What the heck are you talking about, Warren? Believe it or not, I get this question a lot. For those who don't know me, I play a disagreeable, contrarian idiot on the internet. I am one in real life too, but I play it on the internet as well. But for me, this stubborn disagreeableness serves a purpose. Although sometimes it is just for fun. A lot of the times, if you post a really opinionated perspective, what you get in return is a bunch of nuance, and it helps you land on kind of a nice, well-rounded opinion, and maybe even find things that you hadn't thought about before. That was supposed to be the slide that I was talking on, so we're off to a good start. So why am I talking about this? Because that is exactly what I'm going to be doing today. That's what the title is. Apps are for writes, sites are for reads. It's pretty like black and white. Obviously, things aren't really that way, but I feel like we're at an incredibly important transitioning point when it comes to software, hardware. So I just kind of want to do a spot check to see where we're at, what we're using, different solutions we have. Got my slides out of order again. Okay, so the web is getting really complicated. We have hydration, which every developer who's had a real job knows what hydration is, but for those who don't, Carson. Hydration is a process of attaching client-side JavaScript behavior to server-rendered HTML to make a web page interactive. The server sends HTML along with the JavaScript bundle, serves the rendered HTML page for first paint, and then goes behind the scenes, hooks JavaScript up for interactivity. A lot of the reasoning behind this was for like SEO, fast first time to paint. But hydration mistakes, man. Hydration errors are everywhere. The second thing that we're really seeing right now is performance. The app should clicky click when I tappy tap. Everybody uses TikTok now, and so they're just like, expect instant gratification. So yeah, we've kind of had to account for that. It's the user's information, and they want it now. Concurrency and accuracy. So yeah, the push for performance is really bringing distributed systems into focus. We've got CQRS, CDRT, and lots of other patterns that are used to try and help consolidate patterns to solve for users acting on shared information across distributed systems. So this really started out, in my mind, with PWAs, but lately we're kind of seeing this spin up of what everybody's calling local first. I think most of this kind of comes down to distribution, which if you'd figure it out already, Dilbert, we would be done. Islands. I don't know if anybody was paying attention with the whole RSC situation and how they were trying to explain the different complexities there, but anytime I'm looking down the complexity barrel of something that I can't seem to really grasp or wrap my head around, I try and figure out where it came from. Like, how do we get here? So then, once I get a grip on that, I can figure out my ideal that I'm working towards and kind of work backwards and fill in the in-between. Because when you know when you're trying to go, when you know where you were, it helps you really minimize a lot of complexities that otherwise wouldn't be necessary. They're good fact checks. So after months of reading, I was reading, believe it, watching and learning everything, history of computers, internet, programming I could find, I learned a ton. Mostly that everything that I was reading was really way off target for what this talk was going to be. But there were two things that did really stick with me. Compute. So the ENIAC, this was actually the first computer, and it was, so the dudes were doing dude things, building things that propel themselves through the air and explode when hitting whatever they were shooting them at. But they had a problem. For every explode that they wanted to boom, it took at least many, many hours of maths. Now, I'm not a ratio expert, but that seems like a terrible ratio. So, enter ENIAC. It's an initialism for something. Basically, using electrical currents and punch cards and stuff, ENIAC was able to produce ballistic missile reports for every scale in 30 seconds. And previously, that had taken like days. Days, months, weeks. But what they had done is humans had found a repetitive task, provided a machine the formulas, and had it do their dirty work. Hey dude, did you get my letter? We're discovering all this low-key skibidi information. And I wrote it all down, and a guy with a horse picked it up and rode through the night, and this should be in your mailbox now. Have you read it and copied the rizzed out results to your own notebook yet? So, compute was born and starting to thrive. We were making all these awesome advances, but we couldn't share them with each other. Not only could we not share them with each other, computers didn't even speak the same language. They didn't even know that other computers existed. They were just a giant brain bucket silo of, yeah. But that's a problem. That's a problem for learning because all of our knowledge comes from previous generations. We're building on everything our predecessors learned. We want to work together in real time. We want to be able to share our compute. And so that's when ARPANET came around. It was commissioned in 1966. DoD funded, of course, like literally everything in tech. Stood up 4 nodes initially: UCLA, Stanford, UCSB, Utah. The first message was sent in 1969. Reduced communication lag from days to seconds. It used interface message processors. It paved the way for TCP/IP, and it was invented by Al Gore. Then we had the browser. The browser, this could be a third thing, but I didn't make it a third thing because the way that I look at the browser is network protocols. You're trying to efficiently send a message across the country in a performant manner while having the other end of the transmission receive the information exactly like it was sent. So that's why I look at the browser as a virtual machine. Really, it's a GUI portal for the network. It uses HTML, CSS, JS to display network disseminated information. It is the enforcement of rigorously battle-tested universal networking standards, unless it needs a date picker. Yeah, so really, I'm counting the browser more as the network, because that's really all it's doing, is we're sending messages from one place to another, and we want to make sure that whoever receives the message can see it the way that it was sent. So those are my two big takeaways, really, were compute and networking. So the next thing I'm going to do is take a look at how sites work. So sites start with a web dev. The web dev builds an app, pushes the bundle to a server, and then users make requests to said server. So looking at this, what's your source of truth? It's the server, right? Duh. That makes sense? Oh, that's really loud. Sorry. Looking at this from a different angle, we can see the users making requests to a server for a snapshot of information at a certain point in time. There's no need for versioning. The user wants real-time, accurate information. They make a request, and that's exactly what they get. There's just one issue. The server could be states away, and each network request requires a round trip, which is constrained by the speed of light. We have no choice. We got to make it faster. So, and we can make it faster. We can spin up replica databases and put them closer to the user. 300 IQ play. Of course, this does come with some trade-offs. Replica 1 may not be in sync with the master DB. Same goes for Replica 2. Replica 1 might not have up-to-date changes made to shared information on Replica 2. Master may get updated and need to push changes to a replica, but the replica's information has been acted on by somebody else. It sounds really complicated, but I promise it's not actually that complicated. It's pretty easy to implement. But now we're making it faster. We're going to put the server on the client. CDRT fixes this. It's easy. It's not a big deal. Now every action is recorded immediately. We don't have any spinning loaders. We have interactive content. People are mutating data, shared data at the edge, consolidating and diffed, and consolidated and diffed. And on rare occasion, we may need to migrate our schema, but that's okay because we're versioning now. So basically every time that we have a schema update, we increment the endpoint, and we sunset the old endpoint after all of our users have bumped to the new version. So like I said, it sounds complicated. It's not, I promise. Then we have browsers. We do have different browsers on every single machine. So, actually crap, this is an old slide. We're a DIA team now. Okay, tabs. I also forgot about tabs. So I guess there is quite a bit to manage when we are trying to increase the speed of light performant internet to be a little bit faster for users on their devices. But yeah, pretty sure you guys are catching on. Like simple graph, x-axis, y-axis, server proximity to user, number of complexity daemons. So the further that we get from our server, the more complexity daemons we end up battling. So what's this look like for native app devs? We have a native dev. The native dev builds a native application. It pushes the bundle to the client. And we can back that up to the server if we want to, but that's not required. So where's your source of truth here? It's on the actual client. The distribution model is different. You guys recognize these pics? Crash Bandicoot? Get you? Yeah? Heck yeah. What about Tonka Construction? What? It was an incredible game. You guys are missing out. So if we think back to CDs were really pushes to polycarbonate plastic. Users went to a store, they bought your CD, they drove home, they stuck it in their tray, and then they ran that application on their machine. This is what I'm calling hydration in the 90s. The application lived perpetually because, the application lived in perpetuity. I should have picked a different word, that's hard. In perpetuity because the client owned the disk, which encapsulated said application and its state in its entirety. Sure, like next year they might release a new version, but as a user, I don't have to go buy that new version, and I can still run my old version perfectly fine because I have the CD for it. So basically what you have there is versioning is baked into the process, right? Since you're shipping the actual bundle to the client. So if we look at things today, Office Depot, App Store, Google Play, same thing. They are. It's just like buying a CD, taking it home. The only difference is that bandwidth has increased to the point that we can now just sit at home, eat tacos, and download CDs over the internet. All the other aspects, the versioning, the persistence, the no network requirements, those are all pretty much held intact. Believe it or not, this is a valid UML diagram. It is. That is all you ever need to get a native application to run. Just need your device. Here's the weird part, though. What? If native apps are already living and serving compute purposes on the client, why are we treating them the exact same way we treat our sites, aka the networking? Why immediately are we lifting our source of truth and introducing the complexity of distributed systems when the native app we're shipping is perfectly functional in its self-contained environment? It doesn't make any sense. So what does make sense? What are the tiers of increasing concerns? Native applications operate in the context of their user. Keeping this principle front and foremost in foremind and on your brain before anything else that is ever you think about, we can avoid most complexity if we need to build out a distributed system. The first thing people always ask about backups and redundancy. Well, similar to the save button for the CD games, we can just export a CSV. That is a valid means of persisting application state. We can also write to an external disk. That one's a little bit nicer because we're consistently writing. We're backing up to a removable storage that we can jump between devices. SD cards are going to come back. It will be the last thing I do on this earth. I will see that removable storage is brought back to the people who deserve it. Alternatively, we can also back up to a server. This is arguably a little bit more flexible, makes a little bit more sense, depending on the application. The nice thing about being on a server is now if you're trying to run on multiple devices, we can do that. We can keep these two applications in state. But the main context here is that all of this is happening within the context of that specific user, their device, that's it. So there's different ways to kind of handle the diffing here. Most people don't run apps at the same time, even if they have multiple devices. So what you can do is you can just blow away the entire state on app first load. If they do happen to be both running it, and you can be checking for this, you can set up streams or pub sub, channels, sockets, whatever you want, and just use plain old queues, really, to get them to talk to each other. Sharing devices. So if native apps are operating in the context of the consumer, it's pretty easy to think about what sharing users' personal app state might look like. So if we think about a user's personal app state, if I'm at the middle, then everything around me is a document or a bucket or I'll have a list of to-dos, and then I might have a list of to-dos in the backyard, and then I might have a list of to-dos in the front yard, and then I might need to walk my dog, or I don't know. So you can think about data in that way. And so if we're coming from a mobile-first perspective, it's very easy for me to say, hey, I need to share this aspect of this bucket with some other users. So I set the permissions, I push them up. Those can still be tied to my user on somebody else's device, but we don't need an entire shared network to be able to opt into updates, which seems like that's the default, as opposed to selectively choosing which information I want to share. And then we have some other approaches that I think are a little bit more out there, but kind of cool. You have like on-demand, spin up local groups where you have users with devices and they're all operating in the same context. So say you have a group of emergency responders, something like that. They all care about the same situation, but it's a one-time situation. So what we could do is lift that source of truth up just a tier, and then, we're just missing a lot of that complexity that would otherwise be there. So I think this kind of makes sense too, maybe, the native side of things. The level of back-uppedness, connectedness from the user, so the further we go up, the more complexity demons we add. And that's really kind of the entire premise of this whole talk, and what I was trying to get across is that on the web, things get more complicated the further we get from the server. Whereas native apps, complexity increases as we work our way up to a server, or whatever that might look like in the future. Some interesting concepts for the future that I'm working on. Real NoSQL has never been tried. It hasn't, okay? I'm messing with some couch-based stuff that's really cool. And so that's kind of just shifting your perspective about an application's data living on the client, pertinent to a user. I think that just kind of lends its hand to NoSQL or JSON. I keep trying to say documents, and Trav's like, you're using JSON. But I just think there's a cool relationship there. I think we might even be able to bring some of these servers down with some of these mesh networks and get these devices actually talking to each other. I mean, it's early yet, but we tend to make things better over time. And I think there might be some cool breakthroughs there. Then also just some on-demand shared resources. And we're just gonna see what we can do. But yeah, that's my talk. Thanks, everybody.
Woo.
What's up?
Well done. All right, so first question, very important. From the CD-ROM era,
Yes.
I'm a Red Alert 2 man.
Okay.
What was your game of choice back in the day?
Ooh,
Say Doom.
not Doom.
Perfect, good answer. I told you the questions would be easy, and
I know,
if not,
this is the
was
hardest
easy. Yeah,
one.
this is a harder question. I apologize for that.
We played a lot of Aladdin, so that Tonka game that was up there.
Okay.
Some Sims, some toy roller coaster.
No Red Alert franchise whatsoever.
I actually have never even heard of that.
Oh, gosh. Any Red Alert fans in the audience? Okay, thank you. So I'm not crazy.
Broke Aaron Francis's heart.
Last question for you. When you do have to get into distributed systems, things become necessarily complex. How do you learn that kind of stuff? Because that seems like next level. So where do you go to pick that up?
Unironically, I've been watching a lot of CDRT videos, CQRS. Those are pretty interesting ways to tackle distributed systems. So I'll hit YouTube and just kind of watch videos about how other people are exploring that. And then on top of that, sometimes I just build stuff. Like you can just build things and it'll be wrong, but then you can rebuild it again a little bit more right, and then you keep rebuilding it more and more right.
I like that. You can just build things. Y'all give it up for Warren. Good job.
Thanks, guys.